Hello, how are you doing? This is Mike here, and today we're going to determine some areas enclosed by curves and different axes, as well as some lines. So in order for us to tackle this problem, I'm not really going to go and dwell too much into graphing the functions. I'm just going to graph the portions that need to be graphed and to evaluate them. So this is an area question. We could see this either in a Calculus 1 or a Calculus 2 class. So let's go ahead and try graphing the portion that we care about. We see that we have the curve x plus 4 over x squared. It's bound by the x-axis, the vertical line x equals to 2, and the vertical line x equals to 4. So this is going to look something like this, and the portion that we care about is going to look something like this. And we have the line x equals to 2, and then the line x equals to 4. I'm going to enclose them using a blue value. So this is the vertical line x equals to 2. This is the vertical line x equals to 4. And then we're also bound by the x-axis, which is this guy right here. So we are looking for this area. I am roughly shading in or drawing lines throughout, and yeah, something like that. So we recognize that this area exists above the x-axis, so we expect it to be a positive area, as well as the fact that that it is a small integral. We're only going from 2 to 4, so it shouldn't be that large. We shouldn't be getting huge numbers because we're integrating from 2 to 4, and x plus 4 over x squared is relatively close to the x-axis of these 2 points. So let's go ahead and figure this out. We are going to integrate from 2 to 4, and our function is x plus 4 all over x squared, and this is going to be integrated with respect to x. And this is a fundamental theorem that we should know at this level. We are going to integrate from the lower bound to the upper bound of our function, and we are safe with this because it's enclosed by the x-axis. If it was enclosed by a different axis, we'd have some work to analyze a little bit further, but for right now we should feel pretty safe about this. I'm going to go ahead and rewrite this as the integral from 2 to 4 as x plus 4x to the negative 2 power evaluated with respect to x. Whoops, I just lost half my curve. I don't know why it does that sometimes. And so hopefully you saw that. So now we're going to integrate this. So we're going to have x squared all over 2 plus 4x to the negative 1 divided by negative 1. And this is going to be bound from 2 to 4. Again, that's bound from 2 to 4. And I'll just rewrite this because it annoys me when it just starts depleting. So in order for us to evaluate this integral, we are going to pull out, I'm going to pull out a value of 1/2 to make it easier on myself. So this will give us a value of x squared plus 8 all over x. I'm sorry, that should be a minus. That should be a minus 8. A minus 8 all over x, a minus because we have this divided by that negative 1 power. And we're going to bind this between 2 to 4. Plugging in the upper bound, we have 1/2. We have 16 minus 2. Plugging in the lower bound, we're going to have 4 minus 4. That's relatively nice. And this goes away and comes to 0. And we will have 16 minus 2 is a value of 14. 14 divided by 2, and this gives us a value of 7.